In the form of invention illustrated in Fig 24, the herringbone pattern of weld lines 46B, 46C results in the insole lying substantially flat, thereby facilitating its assembly in a shoe. The rear portion of the insole may curl to a slight extent, but the herringbone front portion resists its curling and reduces it to such an extent that it does not interfere with assembly in the shoe. The herringbone-shaped weld lines are much stronger than the dot weld areas 648, and the corresponding weld regions shown in Figs 20, 21, and 22, resulting in the insole 30A having a much longer life and greater reliability. In addition, the insole is more uniform in thickness. The herringbone pattern also contributes to longer weld lines that enhances the overall strength of the weld regions considerably, making them more capable of withstanding extreme stresses that might be imposed upon them as a result of being subjected to the shock loads encountered in sporting activities, such as running and jumping. The form of invention illustrated in Figs 27 to 29 is generally similar to Figs 24 to 26. Its weld lines 46th throughout the insole are of a sinusoidal shape, resulting in the insole lying flat with its rear portion free from the curling tendency. The chambers 50D are in intercommunication with each other because of the spaces 55T provided between the confronting weld area terminals, 54B, 56B, enabling the gas pressures to be the same throughout the insole at any instant of time. The insole illustrated in Fig 27 is strong and durable, but not quite as strong and durable as the insole shown in Fig 24. In the form of invention disclosed in Figs 30 and 31, the insole is formed, as in all the other embodiments, by upper and lower layers 40B, 42B of elastomeric material, the layers being welded to one another at the peripheral weld line 44C. Within this line are spaced hexagonal weld lines 46E, arranged in a triangular pattern with respect to one another to form hexagonal chambers. 50E. Each hexagonal weld line 44C has spaced terminals 54D, 59D, permitting fluid communication between the interior of each hexagonal chamber 50E and a chamber region 50F surrounding the weld line. Thus, all chambers and regions intercommunicate, with a change in pressure in one portion instantly being reflected in the same fluid pressure being present in all other chamber portions of the insole. Adjacent longitudinal rows of hexagonal chambers 50E are offset with respect to one another, effectively forming annular chambers 50F around each hexagonal chamber. The insole disclosed in Fig 30 inherently lies flat, which facilitates its assembly in the shoe. As is true of the insoles disclosed in Figs 24 and 27, the design depicted in Fig 30 has a long life and great reliability. There are less stresses imposed upon the weld lines during walking, running, and jumping than occurs in the dot weld patterns shown in Figs 17 and 19 to 23. Inclusive. Modified forms of moderator structures are disclosed in Figs 32 and 33. As shown therein, an inflated insert or insole 30X is disposed within a shoe and bears upon its outer sole 62. The moderator structure includes a semi-flexible member 32, which has an underlay 32A, of elastically deformable material attached thereto, such as a foam or foam-like material, which bears upon the inflated insert 30X, forming a cushion between the moderator member 32 and the insert. In use, the underlay 32A will be pressed into conformance with the insert and assist in transmitting the load between the insert 30X and the moderator member, preventing a slipping action from occurring between the moderator structure and the insert. Typically, the underlay 32A may be made of foamed elastomeric material, such as natural rubber, neoprene, polyethylene, ethylene, vinyl acetate, copolymer, polyropylene, ethylene, vinyl acetate, copolymer, polyurethane, and the like. As shown in Fig 33, an overlay 32B of a foamed material can be adhered to the upper surface of the moderator member 32, with the moderator member bearing against the inflated insert 30X. The overlay 32B can be made of the same materials as the underlay 32A of Fig 32. The impression of the foot are formed therein, which tends to prevent slipping of the foot relative to the overlay and moderator member. If desired, both a foamed underlay 32A and overlay 32B can be adhered to opposite sides of the moderator member 32, which is made of relatively stiff material capable of bridging the spaces between the chambers of the inflated insert or insole. In the form of invention disclosed in Figs 34 and 35, an inflated insert or insole 80 is placed within a cavity, 81 in the outsole or elastic heel portion, 82 of a shoe, having a counter 83 suitably secured to the heel portion, a conventional insole 84 resting upon the upper surface of the outer sole 82. If desired, a suitable wear surface or tread 85 is provided on the lower surface of the outer sole. As shown in Fig 34, the heel 86 of the foot is disposed within the shoe counter 83, resting upon the insole, the outer sole 82, and the inflated insert 80 therewithin being in a no-load condition. When the heel 86 applies a load to the shoe, Fig 35, the outer sole 82 will deflect because of its mid-portion 82A being made of an elastically deformable material, the insert being under compression and yielding in proportion to the compression load applied by the heel. When the load is released, the outer sole or heel 82 and the insert 80 will return to their original no-load condition, as shown in Fig 34. With the arrangement disclosed in Figs 34 and 35, an inflatable insert or insole and a moderator within the shoe counter 83 are not required. When an inflated insert 80 is located within the shoe as an insole, as in Fig 3, the spring-like movement of the foot and inflated insert combination must be accommodated for by the upper portion 83 of the shoe. Under some circumstances, there in insufficient compliance of the shoe upper, particularly in the counter area. If excessive movement exists between the front and the inner sides of the shoe, blisters may be produced on the foot. The above condition is corrected through the location of the inflated insert 80 within the sole or heel element 82, as shown in Figs 34 and 35. Since the walls of the outer sole enclosure are made of elastomerically deformable material, virtually all of the vertical displacement motion is contained within the sole and/or heel member 82. The foot 86 and shoe upper 83 move in unison, without any appreciable relative motion. In this manner, a more firm and precise supportive configuration is achieved with greater freedom from blisters being formed on the foot. With the arrangement disclosed in Figs 34 and 35, greater vertical displacements can be used effectively for applications involving unusually high impact forces transmitted from the foot to the adjacent shoe components. It should be noted that each of the inflated insoles, 130, 230, 330, 430, 530, 630, 730, and 830, shown in the embodiments of Figs 15 to 31, respectively, are preferably made of one of the elastomeric materials described above in conjunction with the embodiment of Figs 1 to 13, and each of the insoles is preferably inflated with one of the super gases described above, in conjunction with the embodiment of Figs 1 or 13. In addition, the pressures to which the insoles of the embodiments of Figs 15 to 31 are inflated are preferably within the pressure ranges set forth above in conjunction with the embodiment of Figs 113. It is contemplated that an inflatable insole constructed in accordance with the teachings of the present invention may be used in a unique method of fitting a wide range of foot sizes, shapes, and widths within a given area of a boot, shoe, or other article of footwear. In this connection, it is noted that the space in a conventional boot or shoe is, in all areas, tapered inwardly, including that portion of the boot or shoe which encircles the heel. Figure 14 shows an inflatable insole 930, very similar to the insole 30 shown in the embodiment of Fig 1, provided with an inflation tube 902 having a check valve 904 connected thereto. The valve 904 is adapted to be connected to a source of fluid under pressure for inflating the insole 930. To fit a user's foot to a particular boot, shoe, or other article of footwear, the insole 930 is inserted in a deflated condition in the bottom of the article of footwear. Preferably, a moderator, such as moderator 32 shown in Fig 2, is inserted in the article of footwear overlying the inflatable insole 930. Thereafter, the wearer's foot is inserted into the article of footwear, and the footwear may be tied or buckled or otherwise secured around the foot. Fluid under pressure is then introduced into the inflatable insole 930 through the valve 904 and the tubing 902. As the insole 930 is inflated, the thickness of the insole is gradually increased to gradually raise the wearer's foot upwardly into the smaller, inwardly contoured portions of the footwear until a proper fit of the foot in the footwear is achieved. There are several advantages which flow from this method of fitting an article of footwear using the inflatable insole construction of the present invention. A variety of foot sizes, shapes, and widths may be fitted in a single given boot or shoe. This greatly simplifies complex fitting problems, reduces manufacturing costs, since only a few sizes of footwear need be manufactured, reduces inventory and stock costs, and reduces sales costs. In addition, this method of fitting using the inflatable insole construction of the present invention may be used for fitting footwear which has been used, e.g., hand-me-downs or second-hand footwear, on the feet of children or adults. The valve 904 and inflation tubing 902 may be built into the footwear to be fitted. From the foregoing, it will be apparent that the inflated insert or insole construction of the present invention will comfortably support the foot of a wearer and gives rise to a number of advantages over the insert or insole constructions of the prior art. To name a few of these advantages: 1. The improved construction distributes the normal forces encountered in standing, walking, running, and jumping over the load-bearing portions of the plantar surface of the foot in a uniform and comfortable manner. 2. The improved construction expands the normal load-bearing area of the plantar surface of the foot so as to reduce pressure point loading against the foot. 3. The improved construction forms a dynamic, self-contouring, load-supporting surface which automatically and instantly shapes and contours itself to the constantly changing load-bearing area of the plantar surface of the foot. 4. The improved construction absorbs localized forces, e.g., from stones, irregular terrain, etc., and redistributes these forces away from the localized area and absorbs them throughout the pressurized system of the insert or insole. 5. The improved construction protects the feet, legs, joints, body, organs, brain, and circulatory system of the wearer from damaging shock and vibration forces. 6. The improved construction stores and returns otherwise wasted mechanical energy to the foot and leg of the wearer in a manner so as to reduce the energy of locomotion consumed in walking, running, and jumping, thereby making these activities easier and less tiring for the wearer. 7. The improved construction provides a working fluid in a system of interconnected fluid chambers, which, in conjunction with the moderator, function as fluid springs to absorb shock forces, while providing a firm and comfortable support for the foot of the wearer. 8. The improved construction supports both compression and shear forces encountered in walking, running, and jumping. 9. The improved construction exhibits pre-selected fluid spring rates in one area of the insert or insole substantially different from fluid spring rates in other parts of the insert or insole, and the fluid system in the insert or insole is comprised of a multiplicity of interconnected chambers, wherein the fluid pressure throughout all of the chambers is nominally the same at any given point in time. 10. The improved construction converts displacement energy of the foot to pressure energy within the insert or insole, and transfers this variable pressure energy to various areas of the insert or insole to provide controlled degrees of support as required, in rhythm with the increasing need for support during walking, running, or jumping activities of the wearer. 11. The improved construction has pressurized fluid-containing chambers in areas which underlie the sensitive arch area of the foot, and which areas recede away from contact with the sensitive arch area to allow the plantar tendons in the arch to move and flex freely without interference, except during selected portions of the walking or running cycle, when the pressurized chambers move into supportive contact with the arch area. 12. The improved construction provides essentially permanent, unchanging beneficial characteristics to the foot throughout the life of the article of footwear in which the insert or insole is incorporated. 13. The improved construction permits easy adjustment of the level and degree of its functions by merely changing the initial inflation pressure of the insert or insole, to thereby permit a single design to be used and optimized to fulfill a wide range of specific footwear applications, i.e., standing, walking, running, jumping, etc. 14. The improved insert or insole construction provides a highly efficient barrier to both thermal and electrical energy. 15. The improved construction, consisting of an inflatable insert or insole and a ventilated moderator, provides a system which forces air circulation and ventilation beneath and around the wearer's foot to reduce moisture accumulation throughout the article of footwear in which the improved insert or insole construction is incorporated. 16. The improved insert or insole construction provides a system which massages the foot in such a way as to improve and stimulate blood circulation while the wearer is walking and running, and which does not interfere with blood flow through the foot while the wearer is standing. 17. The improved construction is durable and reliable, and particularly when the insert or insole is inflated with one of the super gases identified above in connection with the embodiment of Figs 1:13, the improved insert or insole construction has a life expectancy of at least several years. 18. The improved inflated insert or insole construction, when inflated within the specified pressure range, assumes a precise predetermined volume, shape, and surface contour in the freestanding no-load condition, so that neither the moderator nor the adjacent surfaces of the shoe are required to achieve said freestanding shape, size, and contour. In some of the embodiments of the inflated insole construction, the freestanding size and shape will approximate the contours of the plantar surface of the foot. In other of the embodiments described above, the freestanding size and shape of the inflated insert or insole may be of uniform thickness to accurately fill in specific volumes or cavities within the sole of the shoe. 19. The improved inflated insert or insole construction is designed to operate at sufficiently high pressure levels so that the individual fluid chambers in the insert or insole act in combination with the moderator to form a complex, interconnected pneumatic spring system capable of supporting all or a substantial portion of the body weight of the wearer. And the improved insert or insole construction is of high durability, long life expectancy, and capable of meeting or exceeding typical shoe industry standards and specifications. 20. The inflatable insert or insole construction, e.g., Fig 14, may be utilized in a unique method of fitting a wide range of foot sizes and shapes within a relatively few sizes of articles of footwear. 21. The insole construction of the present invention absorbs and transfers shear forces between the foot and the ground in such a manner as to reduce irritation to the plantar surface of the foot, thereby reducing problems of corns, calluses, and blisters. It is contemplated that numerous changes, modifications, and/or additions may be made to the specific embodiments of the present invention shown in the drawings and described above without departing from the spirit and scope of the present invention. Accordingly, it is intended that the scope of this patent be limited only by the scope of the appended claims. I claim 1. An inflated insert construction for articles of footwear comprising a sealed insert barrier member of permeable elastomeric material providing a plurality of chambers, said chambers being inflated with a gaseous medium under pressure to a desired initial value, said gaseous medium in said chambers comprising a gas other than air, oxygen, or nitrogen, said elastomeric material having characteristics of relatively low permeability with respect to said gas to resist diffusion of said gas therethrough from said chambers, and of relatively high permeability with respect to the ambient air surrounding said insert to permit diffusion of said ambient air through said elastomeric material into each of said chambers to provide a total pressure in each chamber, which is the sum of the partial pressure of the gas in each chamber and the partial pressure of the air in each chamber. The diffusion rate of said gas through said elastomeric material being substantially lower than the diffusion rate of nitrogen through said elastomeric material. 2. An inflated insert construction according to Claim 1, said ambient air diffusing through said insert member and increasing the pressure in said chambers above said initial value. 3. An inflated insert construction according to Claim 1, wherein said elastomeric material of said insert member is an ether-based polyurethane. 4. An inflated insert construction according to Claim 1, wherein said elastomeric material of said insert is polyurethane, polyester elastomer, butyl rubber, fluoroelastomer, chlorinated polyethylene, polyvinyl chloride, chlorosulfonated polyethylene, polyethylene ethylene vinyl acetate copolymer, neoprene, butadiene acrylonitrile rubber, butadiene styrene rubber, ethylene propylene polymer, natural rubber, high-strength silicone rubber, low-density polyethylene, adduct rubber, sulfide rubber, methyl rubber, or thermoplastic rubber. 5. An inflated insert construction according to Claim 1, said chambers being initially inflated with a mixture of said gas and air. 6. An inflated insert construction according to Claim 1, said chambers being initially inflated with a mixture of said gas and nitrogen. 7. An inflated insert construction according to Claim 1, said chambers being initially inflated with a mixture of said gas and oxygen. 8. An inflated insert construction according to Claim 1, the elastomeric material forming said chambers expanding due to tensile relaxation of said material at a rate commensurate with the diffusion of air into said chambers to provide a greater chamber volume which prevents the total pressure in said chambers from increasing excessively. 9. An inflated insert construction as defined in Claim 1, said permeable material having a wall thickness of about 0.001 inch to about 0.050 inch. 10. An inflated insert construction, according to Claim 1, said insert barrier member being a sole member shaped to substantially conform to the outline of a person's foot. 11. An inflated insert construction according to Claim 1 said chambers being in gaseous medium communication with each other. 12. A inflated insert construction according to Claim 11, one or more of said inflated chambers being of such size and shape as to expand upon substantial increase in the gaseous medium pressure above said initial value. One or more other inflated chambers being of such size and shape as to resist further expansion upon such substantial increase in the gaseous medium gas pressure above said initial pressure. 13. An inflated insert construction according to Claim 11, wherein said gas being either hexafluoroethane, sulfur hexafluoride, perfluoropropane, perfluorobutane, perfluoropentane, perfluorohexane, perfluoroheptane, octafluorocyclobutane, perfluorosilcobutane, hexafluoropropylene, tetrafluoromaden, monochloropentafluoroethane, 1,2-dichlorotetrafluoroethane, 1,1, 2, trichloro-122, trifluoroethane, chlorotrifluoroethylene, bromotrifluoromethane, or monochlorotrifluoromethane. 14. An inflated insert construction according to Claim 11, wherein said gaseous medium under pressure is hexafluoroethane. 15. An inflated insert construction according to Claim 11, wherein said gaseous medium under pressure is sulfur hexafluoride. 16. An inflated insert construction according to Claim 11, wherein the gaseous medium pressure in said chambers is between about 2 psi and about 50 psi. 17. An inflated insert construction according to Claim 11, wherein said insert member comprises 2 layers of elastomeric material sealed to one another at spaced intervals to define a plurality of intercommunicating chambers. 18. An inflated insert construction according to Claim 11, wherein said insert member comprises 2 layers of elastomeric material sealed to one another along seam lines to define a plurality of generally longitudinally extending tubular chambers. 19. An inflated insert construction according to Claim 3, wherein said insole member comprises 2 layers of elastomeric material sealed to one another at a plurality of spaced weld areas to define a plurality of generally annular chambers. 20. An inflated insert construction according to Claim 19, wherein said weld areas are arranged in a pattern of triangles, with each weld area forming an apex of a triangle. 21. An inflated insert construction according to Claim 19, wherein said weld areas are arranged in a pattern of squares, with each weld area forming a corner of a square. 22. An inflated insert construction according to Claim 11, wherein said insert member comprises two layers of elastomeric material sealed to one another at selected points to define said plurality of chambers, said two layers of elastomeric material being sealed to one another along seam lines in one region of said insert member to define a plurality of generally longitudinally extending tubular chambers in said one region of said insert member, and said layers of elastomeric material being sealed to one another at a plurality of spaced weld areas in another region of said insole member to define a plurality of generally annular chambers in said other region of said insert member. 23. An inflated insert construction according to Claim 18, the seam lines in the forward portion of said insert being arranged in a herringbone pattern to form corresponding tubular chambers arranged in a herringbone pattern. 24. An inflated insert construction according to Claim 18, the seam lines being arranged in a sinusoidal pattern to form corresponding sinusoidal tubular chambers. 25. An inflated insert construction according to Claim 11, wherein said insert comprises two layers of elastomeric material sealed to one another along polygonal seam lines to form a plurality of polygonal chambers spaced from each other. 26. An inflated insole construction according to Claim 11, wherein said insert comprises two layers of elastomeric material sealed to one another along hexagonal seam lines to form a plurality of hexagonal chambers spaced from one another. 27. An inflated insert construction as defined in Claim 11, said permeable material having a wall thickness of about 0.001 inch to about 0.050 inch. To 28. An inflated insert construction for articles of footwear comprising a sealed insert barrier member of permeable elastomeric material providing a plurality of chambers, said chambers being inflated with a gaseous medium under pressure to a desired initial value, said gaseous medium in said chambers comprising a gas other than air, oxygen, or nitrogen, said elastomeric material having characteristics of relatively low permeability with respect to said gas to resist diffusion of said gas therethrough from said chambers, and of relatively high permeability with respect to the ambient air surrounding said insert to permit diffusion of said ambient air through said elastomeric material into each of said chambers to provide a total pressure in each chamber, which is the sum of the partial pressure of the gas in each chamber and the partial pressure of the air in each chamber, said gas being either hexafluoroethane, sulfur hexafluoride, perfluoropropane, perfluorobutane, perfluoropentane, perfluorohexane, perfluoroheptane, octafluorocyclobutane, perfluorocyclobutane, hexafluoropropylene, tetrafluoromethane, monochloro-pentafluoroethane, 1,2 dichlorotetrafluoroethane, 1,1,2 trichloro-1, 2,2 trifluoroethane, chlorotrifluoroethylene, bromotrifluoromethane, or monochlorotrifluoromethane. 29. An inflated insert construction according to claim. 28. Said elastomeric material of said insert, being either polyurethane, polyester elastomer, fluoroelastomer, chlorinated polyethylene, polyvinyl chloride, chlorosulfonated polyethylene, polyethylene, ethylene, vinyl acetate, copolymer, neoprene, butadiene, acrylonitrile, rubber, butadiene, styrene, rubber, ethylene propylene polymer, natural rubber, high-strength silicone rubber, low-density polyethylene, adduct rubber, sulfide rubber, methyl rubber, or thermoplastic rubber. 30. An inflated insert construction according to Claim 28, said chambers being initially inflated with a mixture of said gas and air. 31. An inflated insert construction according to Claim 28, said chambers being initially inflated with a mixture of said gas and nitrogen. 32. An inflated insert construction according to Claim 28, said chambers being initially inflated with a mixture of said gas and oxygen. 33. An inflated insert construction for articles of footwear comprising a sealed insole member of elastomeric material providing a plurality of chambers, said chambers being inflated with a fluid under pressure, and a moderator member comprising a sheet of semi-flexible material overlying said insole member and bridging said inflated chambers, said moderator member further including a layer of deformable material engaging one surface of said sheet of semi-flexible material. 34. An inflated insert construction according to Claim 33, said layer being of foam material. 35. An inflated insert construction according to Claim 33, said layer underlying said sheet of semi-flexible material. 36. An inflated insert construction according to Claim 33, said layer overlying said sheet of semi-flexible material. 37. An insert construction according to Claim 1, in combination with an elastic outsole having an enclosed cavity in which said insert is positioned. 38. An inflated insert construction according to Claim 37, said chambers being in gaseous medium communication with each other. 39. An inflated insert construction for articles of footwear comprising a sealed insole member of elastomeric material providing a plurality of chambers in fluid communication with each other, said chambers being inflated with a fluid under pressure, which causes said chambers to expand and form peaks and intervening valleys in the upper surface of said member. A moderator member comprising a sheet of semi-flexible material overlying said insole member and bearing against said peaks and bridging said valleys between said inflated chambers, said fluid under pressure being either hexafluoroethane, sulfur hexafluoride, perfluoropropane, octafluorocyclobutane, perfluorocyclobutane, hexafluoropropylene, tetrafluoromethane, monochloropentafluoroethane, 1-decreene-2-dechlorotetrafluoroethane, 1-bacre-1-2-trichloro-1-2-2-trifluoroethane, chlorotrifluoroethylene, bromotrifluoromethane, or monochlorotrifluoromethane. 40. An inflated insert construction according to Claim 39, wherein said elastomeric material of said insert is either polyurethane, polyester elastomer, fluoroelastomer, chlorinated polyethylene, polyvinyl chloride, chlorosulfonated polyethylene, polyethylene, ethylene, vinyl acetate copolymer, neoprene, butadiene, acrylonitrile, rubber, butadiene styrene rubber, ethylene propylene polymer, natural rubber, high-strength silicone rubber, low-density polyethylene, adduct rubber, sulfide rubber, methyl rubber, or thermoplastic rubber. 41. An inflated insert construction according to Claim 29, wherein said fluid under pressure is hexafluoroethane. 42. An inflated insert construction according to Claim 29, wherein said fluid under pressure is sulfur hexafluoride. 43. An inflated insert construction as defined in Claim 28, said permeable material having a wall thickness of about 0.001 inch to about 0.050 inch. 44. An inflated insert construction as defined in Claim 29, said permeable material having a wall thickness of about 0.001 inch to about 0.050 inch. 45. An inflated insert construction, as defined in Claim 13, said permeable material having a wall thickness of about 0.001 inch to about 0.050 inch.
Want to fall asleep listening to the patents of historic or important inventions? Then subscribe the Sleepy Time for Nerds channel on YouTube and drift into slumber, listening to the detailed description of inventions like Alexander Graham Bell's telegraph, Thomas Edison's light bulb, and even the toilet paper roll. What can be better than drifting off to deep sleep with the historic voices of these inventors? Having trouble sleeping? Let us read you some bedtime stories guaranteed to put you right to sound slumber. We are reading selected patents on a variety of inventions, past and present. While you're falling asleep, you will subconsciously gain knowledge and insight on inventions that advanced our technology in many technical areas and industries. What more could you ask for? Sleepy Time for Nerds is perfect for engineers, scientists, physicists, and the weekend tinkerer. Sleep tight. Subscribe, like, and leave a comment below, and let us know what other patents you want to listen to while you fall asleep.